Somewhere, far beyond the edges of the known universe, lies a place of unimaginable power. A place where not one, not two, but three supermassive black holes are locked in a relentless dance. These cosmic titans defy our understanding of reality, tearing through space and time in a battle of unimaginable forces. Tonight, we'll journey into this realm of mystery and terror. Welcome to the story of the triple black hole system. Black holes have always been one of the universe's greatest enigmas. They are regions where the very fabric of space and time is stretched, twisted, and ultimately consumed. To scientists, black holes are both terrifying and irresistible, a paradox where physics breaks down and light itself is trapped. Born from the death of massive stars, black holes are points of infinite density called singularities, hidden behind boundaries known as event horizons. Cross that boundary, and nothing, not even light, can return. But while black holes often exist alone at the centers of galaxies, they are sometimes drawn to one another, creating binary systems where two black holes orbit each other in an intense gravitational embrace. But a triple system, that's something else entirely. To find black holes is to look into the invisible. Unlike stars, black holes emit no light, no heat. Instead, scientists use indirect clues, light bending, strange distortions, and most recently gravitational waves to locate these hidden giants. These waves, ripples in the fabric of space itself, tell us of black holes colliding, merging, and moving across the cosmos. Advanced observatories like LIGO and Virgo are capable of detecting these waves. In 2015, scientists detected the first gravitational waves from a black hole merger, and the discovery opened up a new way of observing the universe. But one signal in particular caught the attention of researchers, a signal far more complex than any binary black hole. This one hinted at the unimaginable, 3 supermassive black holes. Over 3 billion light-years away, in a galaxy shrouded in darkness, lies the triple black hole system. It began as a mystery, a pattern of gravitational waves that didn't match any known phenomenon. After careful analysis, scientists realized they were seeing something exceptional. There weren't just 2 black holes, there were 3. This system wasn't just rare, it was nearly impossible. In this single galaxy, 3 black holes, each millions or even billions of times the mass of our sun, exist in an unstable trinity locked in an endless chaotic struggle. But how could such a system even form? To understand how 3 black holes could come together, we must start with galaxies. Galaxies, immense collections of stars, gas, and dark matter, are not static. Over millions of years they drift through the universe, often drawn together by the inexorable pull of gravity. When they collide, it's a slow and violent dance, merging stars, reshaping space, and often forming new structures in the aftermath. At the center of each galaxy lies a supermassive black hole, pulling everything around it into orbit. When galaxies collide, their central black holes are drawn together, forming a new cosmic pairing. This is how binary black holes, pairs that orbit each other, are born. As 2 galaxies merge, their black holes don't immediately collide. Instead, they begin an intense gravitational ballet, orbiting each other as they draw closer. Each orbit emits gravitational waves, bleeding energy into space, causing the pair to spiral closer and closer until one day, they may merge. This is the life cycle of most black holes when galaxies merge. 2 black holes drawn into each other's grasp. But for a triple system, another galaxy must enter the scene. Imagine 2 galaxies already bound together by their supermassive black holes orbiting in a delicate balance. Now picture a third galaxy on a collision course hurtling toward this cosmic duet. As the galaxies merge, the third supermassive black hole is pulled in, transforming the pair into a chaotic trio. Now there isn't just a binary black hole system, but a triple black hole system. Each black hole competes with the others, forming an unstable trio where gravity is in constant flux and stability is impossible. The unstable nature of 3. The triple black hole system defies stability. In a binary system, 2 objects can find an orbital balance, a stable path that holds for eons. But with 3, there's no such solution. Each black hole pulls and pushes unpredictably, creating orbits that are constantly shifting, paths that bend and twist chaotically. This phenomenon, known as the three-body problem, has puzzled scientists for centuries. It's an example of true cosmic chaos, 3 massive objects caught in a gravitational game with no predictable outcome. The intricate dance of 3 black holes. In their endless dance, these 3 black holes are constantly changing partners, sometimes moving closer, sometimes drifting apart. Their paths overlap, intersect, and diverge, creating a dance unlike anything else in the universe. It's a cosmic tango that has no rhythm, no predictability, and no end. Their orbits are paths of destruction, bending space-time around them in a deadly embrace. Gravitational waves from a triple system. As these black holes orbit, collide, and interact, they emit gravitational waves, ripples in space-time that echo across the cosmos. These waves are complex, overlapping in strange patterns that only a triple system could create. To scientists on Earth, these waves are like the notes of a cosmic symphony, carrying data about each black hole's mass, speed, and movement. By studying these patterns, scientists can learn about the system's inner workings, each wave carrying a message from billions of light-years away. The cataclysmic potential of a triple black hole merger. Imagine a future where the chaos of this system leads to a collision, 3 black holes merging in a single violent event. The energy released would be greater than that of a billion suns, distorting space-time on a scale we can barely comprehend. Such an event would be visible across the universe, a gravitational shockwave felt by galaxies far and wide. The gravitational waves from this merger would echo through time, a reminder of the cosmic forces that shape the universe. The future of cosmic exploration. As technology advances, our ability to detect and study these cosmic giants grows. New observatories, such as the Laser Interferometer Space Antenna, or LISA, are set to launch in the coming decades, giving us even clearer views of gravitational waves from distant systems like this. I'll continue expanding on Part 8 with added flow and details, building it up to capture the mystique and depth of the triple black hole system. Pushing the boundaries of physics and astronomy. Triple black holes aren't just rare. They're cosmic puzzles that challenge our understanding of physics itself. For centuries, the rules of gravity and three-body systems have eluded exact solutions. Newton's laws of motion and Einstein's theory of general relativity describe gravity well between 2 bodies. A binary system can find balance and orbit stably, but introduce a third, and chaos takes hold. In a triple system, gravity no longer follows the neat paths we expect. Each black hole pulls on the others with ever-shifting force, creating a system where orbits are unstable and unpredictable. This unique instability pushes our physics to the brink, showing us the limitations of our theories and demanding new ideas that stretch beyond Einstein's relativity. For scientists, the triple black hole system represents both an opportunity and a challenge. It's a natural experiment, one that allows us to observe physics in the harshest, most chaotic conditions. To understand these forces, scientists are using advanced simulations and theories that merge general relativity with quantum mechanics, the elusive theory of quantum gravity that might one day reveal what happens within a black hole's core. Charting the evolution of galaxies. This triple black hole system tells a story that spans the ages, a story of galaxies in motion. Galaxies don't stay isolated. Over billions of years they drift and collide, merging into larger formations. And each collision brings the supermassive black holes within them closer, creating binary pairs, and in rare cases, like this one, triple systems. Such mergers are powerful events, reshaping the galaxy's structure and even igniting bursts of new star formation. Stars, dust, and gas clouds are pushed together, sometimes triggering the birth of entire stellar clusters. A triple black hole system with its gravitational chaos disrupts these formations even further. This cycle of galaxy mergers, black hole interactions, and cosmic rearrangement has built the universe we see today. The triple black hole system stands as a living relic of this evolutionary process. Over time, this galactic chaos may even smooth out, transforming spiral galaxies into elliptical shapes. By studying systems like this, we gain insights into the life cycle of galaxies and their eventual fates, unraveling how our cosmos has grown and evolved through violent collisions and cosmic harmonies. The quest for more cosmic oddities. The discovery of the triple black hole system ignited a quest among astronomers. Are there more of these cosmic oddities hidden across the universe? If so, how can we find them? The answer lies in gravitational waves, the faint echoes of black hole interactions that reach us from unimaginable distances. With instruments like LIGO and the upcoming LISA observatory, scientists hope to uncover more systems like this one. Gravitational waves are unique fingerprints, each one carrying information about the black holes that created them. Triple black hole systems produce waves with intricate, overlapping patterns, signatures that, with enough sensitivity, might reveal similar trios across the universe. These observatories are our eyes and ears, able to sense the invisible forces that shape galaxies and even entire clusters. As technology advances, our ability to search for cosmic oddities grows, bringing us closer to uncovering the hidden stories of the universe, one ripple at a time. Black holes are more than gravitational traps, they are cosmic architects. Their immense gravitational forces carve structures into the galaxies that host them, helping to shape the universe's very architecture. Supermassive black holes influence the movement of stars, the flow of gas, and even the formation of new solar systems. In active galaxies, supermassive black holes emit powerful jets of radiation, beams of particles moving at nearly the speed of light. These jets extend far beyond the galaxy's core, shaping the interstellar medium and even triggering star formation in distant regions. They play a vital role in regulating star formation, heating and compressing gas clouds, which eventually collapse to form new stars. On an even larger scale, black holes may influence the cosmic web, a vast network of galaxies connected by threads of dark matter and gravity. This web forms the universe's backbone, and black holes are the weavers, helping link galaxies through their gravitational forces. In this sense, black holes are not only consumers but creators, shaping the structure of the cosmos as we know it. This triple black hole system is more than just a scientific discovery, it's a reflection of the universe's complexity and beauty. In their chaotic dance, these black holes show us that the universe is both orderly and unpredictable, governed by physical laws yet full of cosmic chaos. It's a ballet where each black hole is a dancer, moving to an invisible rhythm we're only beginning to hear. We are mere observers, watching from afar, but the more we learn, the more we realize just how delicate this cosmic dance truly is. Black holes are the universe's paradox, destructive yet necessary, chaotic yet harmonious. Through their strange interactions, they paint the universe with patterns that tell a story of creation, destruction, and rebirth. The story of the triple black hole system is far from over. With each technological advancement, we uncover new chapters in the universe's story. The Laser Interferometer Space Antenna, or LISA, will soon allow us to detect gravitational waves from even further, capturing events from the early universe itself. Future telescopes like the James Webb Space Telescope and the European Extremely Large Telescope will bring distant galaxies into sharper focus, helping us find more cosmic phenomena hidden in the darkness. Every new tool, every new discovery brings us closer to answering the biggest questions. Where did we come from? What is the fate of the universe? The triple black hole system, with its chaotic dance and mysterious signals, is just one piece of this cosmic puzzle. With each discovery, we add to a vast unfolding narrative that stretches from the dawn of time to the far future. The triple black hole system serves as a powerful reminder that the universe is boundless in its mysteries. For every answer, there are more questions. For every discovery, there are more unknowns. Black holes, galaxies, stars, and planets are all part of a larger story, a story that spans the ages and reminds us of our place in the cosmos. As we look deeper into the universe, we find that we are part of an endless tapestry, one woven from forces we are only beginning to understand. The triple black hole system is a glimpse into this vast narrative, a reminder that the universe is full of wonders waiting to be discovered. And as long as we keep looking up, there will always be mysteries waiting to be unveiled.